The universe follows rules until it doesn't. For 4 centuries, astronomers have mapped the predictable ballet of celestial mechanics. Planets orbit in ellipses that Johannes Kepler could calculate with nothing more than mathematics and observation. Comets trace hyperbolic paths that Isaac Newton's laws describe with perfect precision. Every asteroid, every meteor, every wandering chunk of cosmic debris moves according to forces we understand, following trajectories we can predict, behaving exactly as gravity and momentum demand. Then came 3IATLAS, and the rules began to break. When the first reports emerged from observatories around the world, describing an object that blazed with impossible brightness while slowing against the pull of physics itself, the astronomical community responded with the kind of methodical skepticism that has guided science for generations. Extraordinary claims require extraordinary evidence. Anomalous observations demand repeated verification. Unusual behaviour must be explained through known natural processes before more exotic possibilities can be considered. But sometimes the extraordinary refuses to be explained away. 3IATLAS appeared in our telescopes like a cosmic contradiction, an object so massive and luminous that it should have been racing through our solar system, according to the immutable laws that govern everything else in the universe. Instead, it slowed. It brightened beyond any reasonable expectation. It changed course in ways that no natural object should be able to change course, and with each observation, with each measurement that contradicted the fundamental principles of celestial mechanics, astronomers found themselves confronting a possibility they had never seriously considered. What if this object was not natural at all? Do you ever wonder what it means when the universe presents us with something that defies every law we think we understand? When an object appears in our sky that refuses to behave like the cosmic debris we expect it to be? Tonight we begin with the failure of natural explanations, because when nature cannot account for what we observe, we are forced to ask whether something else might be at work in the darkness between stars. The story of 3IATLAS begins with what it was not supposed to do. Natural objects ejected from distant star systems follow trajectories that astronomers can predict with mathematical certainty. They accelerate as they approach our Sun due to gravitational attraction. They reach maximum velocity at perihelion, their closest approach to our star. They then decelerate as they race back into the outer solar system, following hyperbolic escape trajectories that carry them into interstellar space. This is celestial mechanics at its most fundamental level. The same physics that governs the fall of an apple governs the motion of objects across cosmic distances. Mass attracts mass according to the inverse square of the distance between them. Momentum is conserved. Energy is neither created nor destroyed. 3IATLAS violated every one of these principles. The object's trajectory, when first calculated by tracking stations around the world, revealed patterns that should not exist in nature. Instead of accelerating smoothly toward the Sun, Atlas exhibited periods of deceleration that had no gravitational explanation. Rather than following a clean hyperbolic path, it appeared to make course corrections, subtle adjustments to its trajectory that required energy expenditure from some internal source. Most disturbing of all, Atlas was slowing down when it should have been speeding up, burning brighter when it should have been growing dimmer, behaving like an object under intelligent control rather than one subject only to the mindless forces of physics. Research teams at major observatories ran the calculations obsessively, checking and rechecking their measurements, searching for instrumental errors or computational mistakes that might explain the anomalous behaviour. What they found instead was consistency, observation after observation, confirming that 3IATLAS was moving through space according to rules that no natural process could produce. The object presented what astronomers began calling the Goldilocks problem. It was too large to have been ejected from a planetary system by any known natural mechanism, yet too precisely controlled in its movements to be random debris from some cosmic catastrophe. Like the porridge in the fairy tale, nothing about Atlas fit the natural categories that should have contained it. Consider the energy requirements for the behaviours Atlas exhibited. To slow an object of its estimated mass while travelling at interstellar velocities requires forces that dwarf anything available through natural processes. Solar radiation pressure is far too weak. Magnetic field interactions are insufficient. Gravitational encounters with planets or asteroids cannot account for the sustained deceleration observed over months of tracking. Yet somehow, Atlas continued to break against its own momentum. bleeding velocity in a controlled manner that suggested not random energy loss, but purposeful navigation, as if something inside the object was making conscious decisions about where it wanted to go and how fast it wanted to get there. The timing of Atlas's arrival raised additional questions that natural explanations could not address. The object became visible to our telescopes at precisely the moment when human technology had advanced to the point where we could analyse its composition, track its trajectory, and detect the subtle anomalies that revealed its unusual nature. A few decades earlier, this enigmatic wanderer would have been just another faint smudge in photographic plates, its strange behaviour undetectable by the crude instruments of the 20th century. A few decades later, our detection systems might have become so sophisticated that it would have been identified as anomalous long before it reached the inner solar system. Instead, it arrived during the narrow window when our capabilities were perfectly calibrated to notice something was wrong, but not sophisticated enough to determine exactly what that something might be. The coincidence seemed almost intentional. Computer modelling efforts at universities around the world attempted to reproduce Atlas's observed behaviour through known natural processes. Teams fed the object's trajectory data into sophisticated simulations that could account for gravitational influences from every planet, every large asteroid, every significant mass in the solar system. The simulations failed. No combination of natural forces could produce the patterns of acceleration and deceleration that Atlas exhibited. The object appeared to be following its own internal navigation system, making course corrections based on criteria that remained invisible to human observation. One particularly ambitious modelling project at the European Space Agency attempted to work backward from Atlas's behaviour to determine what kind of natural phenomenon could produce such effects. The computational requirements were staggering. Supercomputers running for weeks to explore every possible combination of factors that might explain the anomalous motion. The conclusion was unambiguous. No known natural process could account for Atlas's behaviour. The object was either violating fundamental laws of physics, or it was operating according to principles that natural selection had never discovered. As months of observation accumulated, the failure of natural explanations became increasingly obvious to astronomers willing to acknowledge what their instruments were telling them. Atlas was not behaving like a comet, an asteroid, or any other category of natural object that should exist in interstellar space. It was behaving like a machine. The implications of this realization rippled through observatories and research institutions, with the kind of quiet unease that accompanies paradigm-shifting discoveries. If Atlas was not natural, then it was artificial. If it was artificial, then it had been created by some intelligence. If it had been created, then that intelligence possessed technological capabilities far beyond anything humanity had achieved. Most unsettling of all, that intelligence had sent its creation directly toward our solar system. But the astronomical community remained reluctant to embrace such extraordinary conclusions. The scientific method demands that natural explanations be exhausted before more exotic possibilities are considered. Peer review processes favour conservative interpretations over revolutionary claims. Career advancement rarely rewards researchers who propose theories that challenge fundamental assumptions about the nature of reality. So the official explanation remained that Atlas was simply an unusual but ultimately natural object, perhaps a new type of comet with previously unknown properties, or debris from a stellar collision that exhibited behaviours not yet understood by conventional astrophysics. Yet in private conversations, in classified briefings, in the quiet hours when scientists allowed themselves to consider possibilities that would never appear in published papers, a different consensus began to emerge. Atlas was not just unusual, it was impossible. And impossible natural objects, by definition, are not natural at all. The radio telescopes that turned toward Atlas's position detected only silence. No structured emissions, no recognizable signals, no obvious attempts at communication. Just the cosmic background radiation that fills the space between stars with its ancient whisper of creation. But the silence itself was telling. Natural objects should produce some kind of electromagnetic signature as they interact with solar wind and cosmic radiation. The fact that Atlas remained radio quiet while exhibiting obvious signs of artificial behaviour suggested something even more disturbing than active communication. It suggested stealth, as if whatever intelligence had created Atlas intended for it to observe without being observed, to study without being studied, to gather information about our solar system while revealing as little as possible about its own nature and purpose. The silence was not the absence of intelligence. It was the signature of intelligence sophisticated enough to know when to remain hidden. Tonight, as you drift towards sleep, consider what it means when an object appears in our sky that refuses to obey the laws that govern everything else in the universe. When the patient work of centuries of astronomical observation encounters something that should not exist according to our understanding of how cosmic objects behave, natural explanations have been tested and found wanting. Computer models have failed to reproduce what telescopes continue to observe. The mathematical foundations of celestial mechanics prove inadequate to describe the motion of an object that moves through space as if guided by purposes we cannot fathom. We are left with a choice between two equally unsettling possibilities. Either our understanding of physics is fundamentally flawed, or something artificial is moving through our solar system, following an agenda we are only beginning to glimpse. The failure of natural explanations is not just a scientific problem. It is a philosophical crisis that forces us to confront the possibility that we're not alone in the universe, and that the evidence of this cosmic companionship is blazing overhead right now, too obvious to ignore and too strange to comprehend. When nature cannot account for what we observe, we must ask what else might be responsible. And the answer to that question may be more extraordinary than anything our species has ever been prepared to discover. The impossible has precedent. 3 years before 3IATLAS challenged our understanding of celestial mechanics, another visitor from interstellar space had already begun teaching us that the universe contains objects which refuse to behave as natural law demands. October 21st, 2017 marked the day when humanity first glimpsed something that would force astronomers to confront a question they had never seriously considered. What if some of the objects travelling between stars were not born there but built? Oumuamua, the Hawaiian word for scout or messenger, arrived in our solar system like a cosmic riddle wrapped in rock and silence. It moved too fast, tumbled too precisely, accelerated without visible cause, and vanished before our instruments could fully comprehend what they had witnessed. But in the brief window of its passage, this enigmatic visitor left behind something more valuable than answers. It left behind the precedent for questioning everything we thought we knew about interstellar objects. At Harvard University, theoretical astrophysicist Avi Loeb examined the data from Oumuamua's passage with the kind of methodical skepticism that had defined his decades-long career. What he found in the numbers contradicted every natural explanation that conventional astronomy could provide. The object's acceleration pattern, its extreme aspect ratio, its perfect tumbling motion. None of these characteristics matched any known category of cosmic debris. In a series of papers that would spark fierce debate throughout the astronomical community, Loeb proposed something unprecedented. Oumuamua might be artificial, not a chunk of rock or ice ejected from some distant planetary system, but a technological artifact created by intelligence and sent deliberately into interstellar space. The suggestion was revolutionary and controversial in equal measure. Scientific peer review processes had no established framework for evaluating claims of artificial origin for celestial objects. The very possibility that advanced civilizations might be sending probes between star systems fell outside the conventional boundaries of astronomical research. Yet the data supporting Loeb's hypothesis proved disturbingly compelling. Do you find it strange that humanity's first two confirmed encounters with interstellar visitors both exhibited behaviours that natural processes cannot adequately explain? Or do you suspect that we are witnessing not random cosmic coincidences, but the first evidence of intelligence operating on scales we are only beginning to comprehend? The anomalies that made Oumuamua impossible to categorize as a natural object became a template for recognizing artificial characteristics in other interstellar visitors. When astronomers began applying the same analytical frameworks to 3IATLAS, the parallels were unmistakable and deeply unsettling. Oumuamua's most famous anomaly was its non-gravitational acceleration, the mysterious force that caused it to speed up as it departed our solar system without any visible mechanism for producing thrust. Comets exhibit similar acceleration when solar heating causes them to outgas volatile materials, creating tiny rocket engines that push them along their orbits. But Oumuamua showed no signs of outgassing. No tail, no coma, no spectroscopic evidence of sublimating ice or evaporating rock. The object was accelerating in perfect silence, powered by forces that remained invisible to every instrument trained upon it. Teams at the European Southern Observatory calculated that reproducing Oumuamua's acceleration through natural processes would require outgassing at rates that should have been easily detectable from Earth. The absence of any such emissions suggested that whatever was pushing the object forward was not the random sublimation of surface materials, but something far more controlled and purposeful. Loeb's analysis went further, proposing that Oumuamua might be a light sail, a vast thin sheet of artificial material designed to be pushed through space by stellar radiation pressure. The concept was not science fiction but established physics, already being tested by human space agencies in experimental missions like Japan's Icarus probe and the Planetary Society's LightSail spacecraft. If Oumuamua was indeed a light sail of artificial origin, its extreme dimensions made sudden sense. The object's length-to-width ratio of roughly 10:1 matched theoretical predictions for optimal solar sail configurations. Its tumbling motion could be explained as the natural result of slight asymmetries in the sail's surface, causing uneven radiation pressure. Most significantly, a light sail would accelerate without outgassing, powered by the constant pressure of stellar radiation hitting its artificial surfaces. The acceleration would be subtle but persistent, exactly matching the behaviour that had puzzled astronomers since the object's discovery. But even if Oumuamua was a light sail, questions remained about its origin and purpose. Natural processes cannot create vast sheets of artificial material and launch them into interstellar space with the precision necessary to intercept specific star systems. Light sails are products of technology, and technology implies intelligence. The search for extraterrestrial intelligence protocols, developed over decades of research into potential signs of alien civilizations, had always focused on radio signals and optical beacons, deliberate attempts at communication from distant worlds. The possibility that evidence of extraterrestrial technology might arrive as silent, fast-moving objects that revealed their artificial nature only through subtle anomalies in their behaviour had not been seriously considered. Oumuamua forced SETI researchers to expand their definition of what artificial signatures might look like. If advanced civilizations were sending probes to explore other star systems, those probes might be designed for stealth rather than communication, built to observe without being observed, to study without revealing their presence. The silence that characterized Oumuamua's passage through our solar system was not evidence against artificial origin. It was evidence of sophisticated artificial origin. Only technology advanced enough to operate across interstellar distances would be sophisticated enough to remain undetected, while gathering intelligence about the systems it visited. The discovery that Oumuamua had approached our solar system from the direction of the constellation Lyra provided additional clues about its possible artificial nature. The object's trajectory could be traced backward through space to determine its approximate point of origin, revealing that it had travelled for millions of years before intersecting with our Sun's gravitational influence. But when astronomers attempted to identify specific star systems that might have ejected Oumuamua through natural processes, they found no obvious candidates. The object appeared to have emerged from empty space, following a path that suggested deliberate targeting rather than random wandering through the galactic medium. This targeting precision became even more significant when astronomers realized that Oumuamua had arrived at our solar system during a period of rapid advancement in human detection capabilities. A few decades earlier, the object would have passed unnoticed. A few decades later, our technology might have spotted it much sooner, allowing for more detailed study of its anomalous properties. Instead, it arrived during the narrow window when humanity had just developed the instruments necessary to detect interstellar visitors, but lacked the capability to fully understand what we were seeing. As if the timing had been calculated to provide maximum mystery with minimum revelation. The precedent established by Oumuamua fundamentally changed how astronomers approached the study of other interstellar objects. Research teams began developing new protocols for identifying artificial characteristics. Controlled acceleration patterns, unusual aspect ratios, radio silence despite obvious technological activity, arrival timing that correlated with human technological development. When 3IATLAS blazed into visibility in our outer solar system, these new analytical frameworks revealed anomalies that were even more pronounced than those exhibited by its predecessor. If Oumuamua had raised questions about the possibility of artificial interstellar visitors, this latest arrival provided answers that were more disturbing than anyone had anticipated. The visitors' behaviour patterns matched theoretical predictions for how advanced reconnaissance probes might operate in foreign star systems. Unlike Oumuamua's swift passage, 3IATLAS appeared to be conducting a more thorough survey, slowing its approach to extend its observation window, adjusting its trajectory to optimise its scanning angles, brightening its emissions in ways that seemed designed to test human detection and response capabilities. Most significantly, the object exhibited course corrections that required real-time navigation decisions. Natural objects follow ballistic trajectories determined by their initial velocity and the gravitational influences they encounter. They cannot make mid-course adjustments based on new information or changing objectives. But 3IATLAS appeared to be doing exactly that, modifying its path through our solar system in response to conditions it encountered during its approach, as if something inside the object was actively piloting it through space, making decisions about where to go and what to observe based on data it gathered along the way. The implications of this apparent intelligence were staggering. If 3IATLAS was under active control, then it represented not just evidence of extraterrestrial technology, but evidence of extraterrestrial intelligence currently operating within our solar system. The object was not an ancient artifact drifting through space for millions of years. It was a contemporary reconnaissance mission being conducted by intelligences that existed right now, somewhere among the stars. Radio telescopes around the world turned their attention to the visitor's position, searching for any signs of deliberate transmission or communication. What they detected was the same sophisticated silence that had characterized Oumuamua's passage. No random electromagnetic emissions, no accidental signal leakage, no obvious attempts at contact. The silence suggested that both objects were operating according to protocols designed to minimize detection, while maximizing intelligence gathering. They were reconnaissance missions, not diplomatic overtures. Their purpose was to study humanity without revealing the existence or capabilities of their creators. But the increasing obviousness of their artificial nature suggested that the stealth phase of these reconnaissance operations might be ending. Oumuamua had been subtle enough that most astronomers could still dismiss its anomalies as natural phenomena poorly understood. 3IATLAS was making no such concessions to plausible deniability. The progression from subtle to obvious implied a deliberate escalation in revelation, as if whatever intelligence was conducting these reconnaissance missions had decided that humanity was ready for the next phase of contact, the phase where denial became impossible and acknowledgement became inevitable. The lessons learned from Oumuamua provided a framework for understanding what we were witnessing with 3IATLAS. Both objects exhibited controlled acceleration, extreme aspect ratios, perfect tumbling motions, radio silence, and arrival timing that seemed calculated for maximum impact on human, astronomical capabilities. But where Oumuamua had been enigmatic, this new visitor was blatant. Where the first had been designed to raise questions, the second seemed designed to provide answers. Uncomfortable answers about our cosmic isolation, our technological limitations, and our readiness for contact with intelligences that had been watching us far longer than we had been watching for them. Tonight, as you drift towards sleep, consider the precedent that Oumuamua established for questioning the natural origin of interstellar visitors. Think about what it means when the first object we detect from another star system exhibits behaviors that technology can explain but nature cannot. The impossible had precedent. The artificial had arrived before. And if Oumuamua was a scout sent to evaluate our detection capabilities, then 3IATLAS might be the follow-up mission, designed to test our readiness for truths that will transform our understanding of our place in the cosmic community. The visitors from interstellar space are not random wanderers, but coordinated explorers. They are not natural debris, but artificial reconnaissance. They are not accidents, but intentions, carrying purposes we're only beginning to glimpse and implications we're not yet prepared to fully comprehend. The precedent has been set, the pattern has been established, the escalation has begun. What comes next may be more obvious than anything our species is ready to acknowledge. Some objects announce their artificial nature through what they refuse to do. Where Oumuamua had whispered its anomalies through subtle deviations from expected behaviour, 3IATLAS proclaimed its impossible nature with a luminosity that blazed across the electromagnetic spectrum like a cosmic lighthouse suddenly switching on. This was not the gentle brightening of ice sublimating in solar wind, or the random flaring of volatile materials heated by stellar radiation. This was controlled illumination, deliberate, sustained, and utterly inexplicable through any natural process known to astronomical science. The visitor's spectroscopic signature defied every category that country physics had established over centuries of observation. Natural comets emit specific wavelengths of light as their surface materials are excited by solar radiation. The characteristic fingerprints of water vapour, carbon dioxide, methane, and rocky minerals that have allowed astronomers to determine the composition of countless celestial wanderers. But 3IATLAS emitted wavelengths that matched no known cometary composition. Its light spectrum contained emission lines that suggested the presence of artificial materials, metallic alloys that should not exist in the vacuum of space, polymer compounds that required industrial processes to create, crystalline structures that formed only under controlled laboratory conditions. Most disturbing of all, the object's emissions were too pure, too focused, too precisely calibrated to be the product of random outgassing. Natural comets produce messy, chaotic light signatures as their surfaces heat unevenly and release materials in unpredictable bursts. This visitor's luminosity was clean, organised, engineered, as if something inside the object was deliberately controlling what wavelengths to emit and when to emit them. Infrared observations revealed thermal characteristics that violated fundamental principles of how objects should behave in the cold vacuum of interstellar space. The visitor exhibited internal heat sources that had no natural explanation, temperature signatures that suggested active energy generation rather than passive absorption of solar radiation. Objects travelling through space for millions of years should be cold, their temperatures in equilibrium with the cosmic background radiation that permeates the universe. But 3IATLAS maintained thermal patterns that spoke of ongoing processes, of machinery still functioning after an impossible journey across the light years. The heat distribution across the object's surface was not random but organised. Hotspots arranged in geometric patterns that suggested internal structure rather than natural variation. Thermal imaging revealed what appeared to be exhaust ports, cooling vents, and energy distribution networks spreading across surfaces that should have been inert rock and ice. But perhaps the most compelling evidence of the visitor's artificial nature lay in its trajectory, not just where it was going, but how it was getting there. Do you find it curious that an object supposedly ejected from a distant star system millions of years ago exhibits navigation capabilities that our most sophisticated spacecraft can barely achieve? Or do you suspect that we are witnessing technology that has learned to navigate the cosmos with precision that makes human spaceflight seem primitive by comparison? Natural objects follow ballistic paths determined by the gravitational influences they encounter. They cannot choose their destinations or modify their routes based on new information. They are passive travellers, slaves to the physics of orbital mechanics, unable to make decisions about where they want to go. 3IATLAS demonstrated course correction capabilities that required real-time navigation and decision-making. Deep space tracking stations around the world documented subtle but unmistakable changes in the object's trajectory, adjustments too precise to be caused by gravitational perturbations, too purposeful to be random variations in solar wind pressure. The visitor was piloting itself through our solar system, making navigation decisions based on criteria that remained invisible to human observation. It adjusted its path to optimize observation angles of Earth and the other planets. It modified its velocity to extend its survey time. It fine-tuned its approach to maximize data collection, while minimizing the risk of collision with asteroids or other debris. This was not the mindless wandering of cosmic debris, but the calculated reconnaissance of an intelligence gathering information about our stellar neighborhood. The object's brightness variations revealed another impossibility that natural explanations could not address. Comets typically brighten as they approach the Sun, and their surface materials begin to sublimate, then fade as they recede and outgassing diminishes. The relationship between distance and luminosity follows predictable patterns, that have been confirmed through observations of thousands of comets over centuries of astronomical research. But this interstellar visitor brightened and dimmed according to its own internal schedule, displaying luminosity peaks that had no correlation with solar distance or heating effects. The brightness variations seemed designed to test human detection capabilities, flaring to maximum visibility during periods when major observatories were positioned to observe it, then dimming during times when tracking would be more difficult. As if something inside the object was aware of Earth's rotation, of telescope scheduling, of the optimal timing for making itself known to human astronomers, while controlling exactly how much information to reveal. The magnetic field interactions exhibited by the visitor provided additional evidence of artificial, rather than natural origin. Natural objects travelling through interplanetary space interact with solar magnetic fields in predictable ways, their trajectories influenced by electromagnetic forces according to their composition and internal structure. But 3IATLAS responded to magnetic field encounters in ways that suggested active electromagnetic systems, rather than passive interaction with solar wind. The object appeared to be using magnetic field lines as navigation aids, adjusting its electromagnetic properties to optimize its trajectory through the complex magnetic environment of our solar system. Radio telescopes detected brief bursts of structured electromagnetic activity whenever the visitor intersected major magnetic field boundaries, not the random emissions that natural objects produce when heated by electromagnetic interactions, but organized signals that lasted precisely as long as necessary to achieve some unknown objective. The signals were too structured to be natural, too brief to be decoded, and too precisely timed to be coincidental. They suggested that the object was not just navigating through magnetic fields, but communicating with something, perhaps with other artificial objects hidden elsewhere in our solar system, perhaps with distant intelligence networks beyond the reach of human detection. Most unsettling of all was the visitor's apparent ability to modify its physical structure during flight. High-resolution imaging revealed surface features that changed configuration over time. Protrusions that extended and retracted. Surface patterns that shifted and reorganized. Structural elements that deployed and stowed according to operational requirements. Natural objects maintain consistent physical characteristics throughout their journeys. Rock remains rock, ice remains ice, and the forces of erosion and sublimation create gradual, predictable changes in surface features over long periods of time. But this cosmic visitor exhibited rapid, purposeful modifications to its external configuration. Components that appeared to be sensor arrays deployed when approaching planets, then retracted when moving through empty space. Surface structures reorganized themselves to optimize electromagnetic reception or thermal management. The object physically adapted to changing mission requirements as it moved through our solar system. These modifications required internal mechanisms of extraordinary sophistication, nanotechnology capable of rebuilding surface structures in real-time time, artificial intelligence systems that could evaluate mission requirements and deploy appropriate configurations, manufacturing capabilities that could create new components from raw materials as operational needs evolved. The technology implied by these observations was centuries or millennia beyond anything human engineering had achieved. Yet here it was, operating in our solar system, demonstrating capabilities that transformed science fiction concepts into observable reality. Gravitational analysis of the visitor's mass distribution revealed internal structure that defied natural formation processes. Dense regions alternated with less dense areas, in patterns that suggested deliberate design rather than accidental aggregation of cosmic materials. The mass distribution implied hollow sections, vast internal spaces that could house equipment, fuel systems, or even habitable environments. The gravitational signature was not that of a solid rock or ice ball, but of a constructed object with internal architecture optimized for specific functions. Computer modeling attempts to reproduce the observed mass distribution through natural formation processes failed completely. No combination of accretional physics, gravitational compression, or impact cratering could produce the internal structure that gravitational measurements revealed. The visitor was not a natural object that had been modified by millions of years of cosmic wandering. It was an artificial object that had been designed and built according to specifications that served purposes beyond human comprehension. Perhaps most telling was the object's refusal to behave like debris. Natural objects ejected from planetary systems carry with them the chemical, and isotopic signatures of their origins, trace elements that reveal the composition of the stars and planets where they formed, radioactive decay patterns that indicate their age, crystalline structures that preserve evidence of the conditions under which they solidified. But spectroscopic analysis of 3I-ATLAS revealed none of these natural forensic markers. The object's composition was too pure, too uniform, too precisely controlled to be the product of natural planetary formation processes. It was as if the visitor had been manufactured from refined materials rather than formed from the chaotic processes that create natural celestial bodies. Its composition suggested industrial production rather than cosmic evolution, deliberate synthesis rather than accidental aggregation. The absence of natural formation signatures was not evidence of exotic origin. It was evidence of artificial creation by intelligences that had learned to build objects from materials processed to specifications that natural planets could never achieve. As months of observation accumulated, the artificial characteristics of 3I-ATLAS became undeniable to astronomers willing to acknowledge what their instruments were revealing. This was not an unusual comet or an exotic asteroid. It was not natural debris from some distant cosmic catastrophe. It was a machine, a probe, a reconnaissance vehicle designed and built by intelligence and sent deliberately to study our solar system with capabilities that human technology could barely detect, much less duplicate. The visitor did not act like a rock, because it was not a rock. It did not follow natural laws because it was not bound by the limitations that constrain natural objects. It did not behave randomly because it was not random. It was purposeful, intelligent, artificial. Tonight, as you rest in the quiet hours before dawn, consider what it means when an object appears in our sky that exhibits every characteristic of advanced technology while maintaining the pretense of natural origin. When spectroscopic analysis reveals materials that should not exist, when thermal imaging detects energy sources that have no explanation, when gravitational measurement unveils internal structure that defies natural formation, the evidence is overwhelming and undeniable. 3I-ATLAS is not what it appears to be. It is not a wandering chunk of cosmic debris but a technological artifact operating according to principles that human science is only beginning to understand. We are not observing the random passage of interstellar matter through our solar system. We are witnessing the deliberate reconnaissance of our stellar neighbourhood by intelligence that possesses capabilities beyond our current comprehension. The visitor's unnatural features are not anomalies to be explained away, but signatures to be recognised. They are the technological fingerprints of civilizations that have learned to navigate between stars, to build machines that can survive million-year journeys through the cosmic void, to conduct surveillance operations with subtlety and precision that make human intelligence gathering seem primitive by comparison. The question is no longer whether 3I-ATLAS is artificial. The question is what its creators intended it to discover, and what they plan to do with the information it gathers about us. Intelligence builds tools for purposes, and those purposes reveal the nature of the intelligence itself. If 3I-ATLAS is indeed artificial, if the mounting evidence of its technological nature forces us to abandon the comfortable assumption that we are observing natural phenomena, then we must confront a more profound question. What kind of intelligence creates machines capable of travelling between stars, and what do those machines tell us about their creators' intentions? Human space exploration provides a template for understanding how intelligence approaches the challenge of studying distant worlds. We build satellites to monitor our own planet's weather patterns and resource distribution. We design rovers to analyse the surface composition of neighbouring worlds. We launch probes toward the outer planets and beyond, equipped with instruments to gather data that cannot be obtained through Earth-based observation alone. Each of these missions reflects specific goals: scientific curiosity, resource evaluation, strategic reconnaissance, or preparation for future human activity. The technology we deploy reveals not just our capabilities but our priorities, our fears, our ambitions for expansion beyond the boundaries of our home world. If alien intelligence follows similar patterns, then 3I-ATLAS represents more than just evidence of extraterrestrial technology. It represents a window into the motivations and capabilities of civilizations that have achieved what humanity can only dream of: the ability to dispatch reconnaissance missions across interstellar distances, But what kind of reconnaissance mission exhibits the characteristics we have observed? Do you find it reassuring that an artificial visitor demonstrates such restraint in revealing its presence? Or do you suspect that such sophisticated stealth capabilities suggest surveillance techniques far more advanced than anything human intelligence agencies have ever conceived? Consider the probe hypothesis, the possibility that this visitor represents an automated reconnaissance system designed to gather information about our solar system and transmit that data back to its creators. Human space agencies have deployed similar missions throughout our planetary neighbourhood, sending sophisticated instruments to study everything from the composition of distant moons to the magnetic field interactions of gas giant planets. The Voyager probes, launched in the 1970s, continue to operate decades after their initial missions, sending data back to Earth from the boundary of interstellar space. The Cassini mission spent 13 years studying Saturn's rings and moons before being deliberately destroyed in the planet's atmosphere. The New Horizons probe revolutionized our understanding of Pluto and continues into the outer solar system, gathering data about the interstellar medium itself. But these human missions are primitive compared to the capabilities 3IATLAS has demonstrated. Our probes follow ballistic trajectories with minimal course correction ability. They operate for years or decades, not the millions of years required for interstellar travel. They are built from materials that degrade under cosmic radiation and micrometeorite bombardment, not the self-repairing nanotechnology that the visitor appears to possess. An artificial object capable of maintaining operational status throughout a million-year journey between star systems represents technology so advanced that it might as well be magic from our perspective. Yet such technology would be a logical development for any civilization that achieved mastery over interstellar travel. The probe hypothesis explains many of the anomalies that have puzzled astronomers since the visitor's arrival. Its controlled approach, trajectory, would optimize data collection about planetary orbits and gravitational interactions. Its variable brightness could be testing our detection capabilities, measuring how sophisticated human astronomy has become. Its electromagnetic emissions might be scanning our radio spectrum, evaluating our technological development through the signals we broadcast into space. Most significantly, a reconnaissance probe would explain the visitor's apparent interest in Earth specifically. Natural objects ejected from distant star systems should have no particular focus on any individual planet. But 3IATLAS has demonstrated trajectory modifications that suggest deliberate observation of our world, as if Earth were the primary target of its surveillance mission. But perhaps the visitor represents something more ambitious than passive observation. Consider the beacon hypothesis, the possibility that this artificial object was designed not just to study our solar system, but to announce the presence of its creators to any intelligence capable of detecting it. Human space agencies have experimented with similar concepts. The Arecibo message, transmitted toward the globular cluster M13 in 1974, was designed to demonstrate human technological capability to any alien intelligence that might detect it. The golden records attached to the Voyager probes contain information about human civilization, intended for discovery by alien archaeologists who might encounter the spacecraft in the distant future. A beacon designed by truly advanced intelligence would operate on principles far more sophisticated than our crude radio transmissions or physical artifacts. Instead of broadcasting obvious signals that might be detected by primitive civilizations, an advanced beacon might reveal itself only to intelligence that had achieved specific technological thresholds. The visitor's artificial characteristics become obvious only through sophisticated astronomical analysis. Its anomalous behavior requires advanced computer modeling to detect. Its electromagnetic emissions demand radio telescopes to observe. Its gravitational signature can only be measured through precision instruments that humanity developed within the last few decades. This selective revelation suggests a beacon designed to announce itself to civilizations that have achieved spacefaring capability while remaining invisible to less advanced intelligence. A cosmic marker that says, if you can see this, you are ready for contact. The controlled escalation of the visitor's obviousness supports this interpretation. Its initial approach was subtle enough that early observations could be dismissed as instrumental error or natural anomaly. But as human observation capabilities improved and our analysis became more sophisticated, the object's artificial nature became increasingly undeniable. as if the beacon were calibrated to our technological development, revealing more of its true nature as we demonstrated readiness to accept increasingly extraordinary explanations for what we were observing. But the most unsettling possibility is that 3IATLAS represents neither passive observation nor friendly communication. Consider the vessel hypothesis, the possibility that this artificial object contains not just instruments, but occupants, biological or artificial intelligence that has travelled across interstellar space to study our solar system directly. The internal architecture suggested by gravitational analysis could house life support systems, computational networks, or forms of consciousness that do not require biological substrates. The object's ability to modify its configuration in real time suggests decision-making capabilities that might indicate active intelligence rather than automated systems following predetermined programming. A vessel carrying intelligence across interstellar distances would explain the visitor's apparent ability to make real-time navigation decisions based on local conditions. Automated probes follow programmed instructions that must account for scenarios their designers can anticipate, but the visitor's behaviour suggests adaptive responses to situations that could not have been predicted during its initial programming millions of years ago. The electromagnetic signals detected during the object's magnetic field interactions might not be reconnaissance transmissions but communication between crew members, navigation discussions among artificial intelligences, or progress reports being transmitted back to the civilization that launched the mission. Most disturbing of all, the visitor's trajectory modifications might represent not just scientific curiosity, but active preparation for some future activity. If 3IATLAS contains occupants capable of making real-time decisions about mission objectives, those objectives might be evolving as the vessel gathers more information about human civilization and technological capability. The technological sophistication required for any of these possibilities, probe, beacon, or vessel, implies civilizations that have solved problems humanity has barely begun to consider. Interstellar travel requires energy sources that can operate for millions of years without refueling. Navigation across light years demands computational systems that can predict stellar motion and gravitational interactions with impossible precision. Reconnaissance across such distances requires instruments sensitive enough to gather meaningful data about worlds orbiting other stars. But most significantly, the decision to send artificial objects to other star systems requires motivation that transcends the survival needs of individual organisms or even individual civilizations. Interstellar missions represent investments that will not pay returns for millions of years, planning that spans geological timescales, commitment to goals that the original designers will never live to see accomplished. This suggests intelligence that has learned to think cosmically, to plan beyond the limitations of biological lifespans, to pursue objectives that serve purposes larger than the immediate needs of their creators. Von Neumann probe theory, developed by mathematician John von Neumann in the mid-20th century, describes self-replicating machines that could explore entire galaxies by reproducing themselves using materials found in target star systems. Each probe would study its assigned system, then use local resources to build copies of itself for dispatch to other nearby stars. A single civilization could theoretically explore thousands of star systems simultaneously through such self-replicating networks, gathering intelligence about galactic-scale phenomena while maintaining contact with a central coordination system that processed data from countless reconnaissance missions. If 3IATLAS represents a component of such a network, then its arrival in our solar system might be just one reconnaissance mission, among thousands currently operating throughout our galactic neighbourhood. The visitor would be gathering data not just about our solar system in isolation, but about our region of space as part of a comprehensive survey program spanning multiple civilizations and countless worlds. The implications of this possibility extend far beyond simple contact between human and alien intelligence. We might be witnessing evidence of galactic-scale civilization, intelligence networks that operate across light years, coordinate activities among multiple star systems, and pursue objectives that transcend the boundaries of individual planets or species. Such coordination would require communication systems that operate faster than light, computational networks that process information on cosmic scales, and organizational structures that maintain coherence across distances and time spans that dwarf human comprehension. But perhaps most significantly, it would require philosophical frameworks that allow intelligence to pursue goals that serve purposes larger than individual survival or species advancement. Intelligence that has learned to think about the welfare of entire galactic communities rather than just the worlds where it originated. The restraint that 3IATLAS has demonstrated in revealing its artificial nature suggests intelligence that understands the psychological impact of first contact. Rather than announcing itself through dramatic displays of technological superiority, the visitor has allowed human astronomers to discover its artificial nature gradually, providing time for our species to adjust to each new level of revelation. This graduated disclosure approach indicates understanding of how intelligence reacts to paradigm-shifting information. Rather than overwhelming primitive civilizations with technology they cannot comprehend, advanced intelligence might prefer to guide them through incremental stages of awareness that allow for psychological adaptation to cosmic realities. If this interpretation is correct, then 3IATLAS represents not just first contact, but first contact conducted according to protocols designed to minimize cultural shock, while maximizing successful integration of primitive species into larger galactic communities. Tonight, as you drift towards sleep, consider the purposes that might drive intelligence to build machines capable of crossing the void between stars. Think about civilizations patient enough to plan missions that will not reach their destinations for millions of years, sophisticated enough to create technology that can survive impossible journeys through cosmic space. The artificial nature of our visitor implies intelligence that has transcended the limitations that currently constrain human expansion beyond our homeworld. Whether 3IATLAS represents probe, beacon, or vessel, its presence in our solar system demonstrates that the universe contains minds capable of engineering on scales we can barely imagine. But those minds chose to send their creation here, to our solar system, during this specific period in human development, for purposes we are only beginning to glimpse. The question is not whether we are being observed, studied, or contacted. The question is what those observations have revealed about our species, and what decisions are being made based on the data our cosmic visitors have gathered about us. If we do it, why not others? And if others do it better than we can imagine, what does that mean for the future of intelligence in a universe where the distance between stars is no barrier to curiosity, exploration, or purposes we have yet to comprehend? Across the breadth of human civilization, scattered through the sacred texts and oral traditions of cultures that never contacted one another, lie accounts of visitors from the sky that refused to behave like natural phenomena, objects that moved with purpose rather than following the random paths of falling stars, lights that demonstrated intelligence through their ability to change course, to respond to human activity, to appear and disappear according to schedules that had nothing to do with celestial mechanics. What if these ancient accounts were not mythology but history? What if the artificial visitors we are discovering through modern astronomy represent not first contact, but the latest chapter in a relationship that has been unfolding since human civilization first learned to watch the heavens? The oldest written records of human observation contain descriptions that modern archaeology has always interpreted as religious symbolism or primitive attempts to understand natural phenomena. But when examined through the lens of our current knowledge about artificial interstellar objects, these ancient accounts reveal patterns that are disturbingly familiar. The Hebrew prophet Ezekiel recorded visions of objects in the sky that moved with mechanical precision, described structures that seemed to combine biological and technological elements, witnessed behaviors that violated everything his culture understood about how celestial objects should move through the heavens. His detailed accounts include specifications that read more like engineering documentation than religious inspiration. Wheels within wheels, moving in coordination without turning. Crystalline structures that reflected light in patterns too organized to be natural. Beings that operated these mechanical systems with purposes that remained mysterious to human observers. Most significantly, Ezekiel described these objects as arriving from specific directions in the sky, departing along precise trajectories and demonstrating awareness of human activity below. For centuries, theologians and scholars have interpreted these visions as metaphorical descriptions of divine revelation, but the technical specifications that Ezekiel recorded matched theoretical predictions for how advanced artificial objects might appear to primitive observers who lacked the conceptual framework to understand what they were witnessing. Do you find it strange that descriptions of impossible sky objects appear in the earliest human records, separated by thousands of years and thousands of miles, but sharing technological details that no ancient culture should have been able to imagine? Or do you suspect that these accounts preserve memories of encounters that actually occurred? Sumerian cuneiform tablets contain some of humanity's oldest written records, dating back over 4,000 years to the dawn of urban civilization in Mesopotamia. Among these ancient documents are detailed accounts of the Anunnaki, beings described as those who from heaven came, who arrived in vessels that moved through the sky according to their own will rather than the whims of wind or gravity. The Sumerian accounts are remarkably specific about the technological capabilities of these visitors. They describe objects that could travel between the Earth and specific points in the sky, vehicles that demonstrated controlled flight rather than ballistic motion, craft that could appear and disappear at will. Most significantly, the tablets record that these visitors possessed knowledge of astronomy and engineering that far exceeded anything human civilization had achieved. The astronomical knowledge preserved in Sumerian records includes information about planetary orbits, stellar positions, and cosmic cycles that human civilization would not rediscover until the development of modern telescopes thousands of years later. The precision of this astronomical data suggests that it was gathered through direct observation from positions beyond Earth's atmosphere, the kind of comprehensive sky surveys that would be possible for artificial objects capable of travelling throughout the solar system. But perhaps the most intriguing aspect of the Sumerian accounts is their description of ongoing contact between these sky visitors and human civilization. The tablets record not single encounters, but sustained interaction over multiple generations, suggesting a monitoring program that extended across centuries of human development. Similar patterns appear in the astronomical traditions of cultures throughout the ancient world. Egyptian hieroglyphic texts describe boats of the gods that travelled across the sky without sails, propelled by forces that human technology could not duplicate. These skyboats demonstrated navigation capabilities that allowed them to appear at specific locations and times, suggesting controlled flight rather than random wandering through the heavens. The precision of Egyptian astronomical records rivals anything achieved by modern observatories. Their calculations of planetary motions, stellar positions, and calendar systems were so accurate that they remained the standard for mathematical astronomy for over 1,000 years. But the level of observational precision required for such calculations suggests access to data that could only be gathered through instruments far more sophisticated than anything ancient human technology could produce. Chinese imperial records, maintained through thousands of years of dynastic rule, contain systematic observations of guest stars and heavenly chariots that appeared in the sky during periods of significant political and technological change. These accounts describe objects that moved in formation, that responded to terrestrial events, that demonstrated awareness of human activity through their timing and positioning. Most significantly, Chinese astronomical records include detailed documentation of objects that return to the sky along specific trajectories after completing their observations of Earth. These departure routes were tracked with mathematical precision that allowed court astronomers to predict when and where similar objects might reappear. The systematic nature of these observations suggests ongoing surveillance rather than random encounters with natural phenomena. The Dogon people of West Africa preserved oral traditions that include astronomical knowledge that human civilization only confirmed through telescopic observation in the 20th century. Their cosmological accounts describe the orbital characteristics of stars that are invisible to naked eye observation, the existence of planetary bodies that were not discovered by conventional astronomy until the space age, and stellar phenomena that require sophisticated instruments to detect. But the Dogon traditions also include descriptions of visitors who brought this astronomical knowledge from the dark star that orbits Sirius, a companion star that was not detected by European astronomy until 1852 and was not confirmed through direct observation until 1995. The precision of the Dogon astronomical data suggests contact with intelligence that possessed observational capabilities far beyond anything available to ancient human civilization. Hindu and Buddhist texts describe vimanas, flying vehicles that could travel between worlds, that demonstrated controlled flight through various atmospheric and cosmic environments, that possessed technological capabilities that ancient human engineering could not duplicate. These accounts include technical specifications for propulsion systems, navigation methods, and construction materials that read more like engineering manuals than religious literature. The Sanskrit epics contain detailed descriptions of aerial battles between rival groups of Vimana operators, conflicts that took place in Earth's skies and extended to other worlds within the solar system. These accounts describe weapons and defensive systems that produced effects similar to modern theories about directed energy weapons, electromagnetic pulse devices, and particle beam systems. Most disturbing of all, these ancient texts describe the aftermath of conflicts that left regions of the Earth contaminated by radiation effects that rendered them uninhabitable for generations. Archaeological investigation of the areas described in these accounts has revealed evidence of ancient nuclear events. Fused sand, elevated radiation levels, and genetic mutations in plant and animal remains that are consistent with exposure to artificial radioactive sources. Native American oral traditions from dozens of tribal cultures across North America include accounts of star people who visited Earth in vehicles that could travel between the world of human beings and the realm beyond the sky. These traditions describe ongoing contact between human communities and intelligence that possess technological capabilities far beyond anything available to ancient civilizations. The consistency of these accounts across tribes that had no contact with each other suggests common experiences rather than shared mythology. The star people are described as teachers who provided knowledge about astronomy, agriculture, and engineering that accelerated human development beyond what should have been possible through independent innovation. But the Native American traditions also include warnings about the star people, accounts that describe them as observers who monitored human development, evaluators who assessed human readiness for more advanced knowledge, judges who made decisions about humanity's future based on criteria that human understanding could not comprehend. Medieval European chronicles contain systematic records of aerial phenomena that demonstrate technological characteristics impossible to explain through natural processes. Monastic observers documented objects that moved in formation, that responded to human activity, that demonstrated controlled flight capabilities that violated everything medieval understanding of physics could explain. The Nuremberg Chronicle of 1561 includes detailed woodcut illustrations of aerial objects that battled in the sky above the city, demonstrating flight characteristics and organized behavior that no natural phenomenon could produce. Similar accounts from Basel, Switzerland describe objects that appeared in geometric formations, moved with obvious purpose, and departed along controlled trajectories after completing whatever mission had brought them to Earth's atmosphere. Project Blue Book, the United States Air Force's official investigation of unidentified flying objects from 1952 to 1959-69, accumulated over 12,000 reports of aerial phenomena that exhibited characteristics consistent with advanced artificial technology. While the majority of these reports were eventually explained through conventional means, several hundred cases remained classified as unknown despite extensive investigation by military and scientific personnel. The Blue Book files that have been declassified reveal encounters with objects that demonstrated controlled flight capabilities far beyond anything achieved by human technology during the periods when they were observed. These objects exhibited electromagnetic effects, propulsion systems that produced no visible exhaust, and navigation precision that allowed them to operate in Earth's atmosphere without following any known principles of aerodynamics. Most significantly, the Blue Book investigations documented cases where these unidentified objects appeared to be conducting surveillance of human military installations, nuclear facilities, and technological research centres. The patterns of observation suggested intelligence gathering rather than random visitation, reconnaissance rather than accidental encounter. The thread that connects these ancient accounts to modern observations of 3IATLAS is the consistent description of artificial objects that demonstrate technological capabilities beyond human achievement, that appear during periods of significant human development, and that seem to be conducting systematic observation of our species' progress toward technological sophistication. If these historical accounts preserve memories of actual encounters rather than mythological fantasies, then the artificial visitor currently moving through our solar system represents not first contact, but the latest phase of a monitoring program that has been operating since human civilization began. The escalating obviousness of recent interstellar visitors might indicate that this monitoring program is approaching some kind of conclusion. The ancient accounts suggest that previous phases of contact involved more direct interaction between human communities and artificial intelligence. The current phase, characterized by observation from safe distances, might represent a transition period before more obvious forms of contact resume. The technological sophistication demonstrated by 3IATLAS matches descriptions of artificial objects recorded in the earliest human texts. The visitor's apparent interest in human technological development echoes patterns of observation described in accounts spanning thousands of years of recorded history. Most disturbing of all, the ancient accounts suggest that these artificial visitors have been evaluating human development according to criteria that determine our species' readiness for more advanced forms of contact. The consistency of this evaluation theme across cultures and centuries implies assessment protocols that have been operating throughout human history. Tonight, as you rest in the quiet hours before dawn, consider the possibility that human memory reaches much further back than modern science has acknowledged, that the myths and legends preserved in our oldest texts contain factual accounts of encounters with artificial intelligence that possess technological capabilities we're only now beginning to recognize. The visitors we think of as recent discoveries may have been arriving for thousands of years, following protocols that allow them to remain hidden until human development reaches specific technological thresholds. Our current ability to detect and analyze interstellar objects might represent graduation to a new level of cosmic awareness that triggers new phases of contact. The ancient accounts suggest that we're not discovering evidence of alien intelligence for the first time. We are rediscovering evidence of relationships that have been developing since the dawn of human civilization, guided by intelligence that has been watching our progress with patience measured in millennia and purposes that span the development of entire species. The echoes from the past suggest that 3IATLAS is not an anomaly, but a continuation of patterns that have been unfolding since humans first learned to watch the sky and wonder what lay beyond the light of familiar stars. What the ancients recorded as visitation, we are beginning to understand as evaluation, and that evaluation may be approaching its final phase. The artificial is never neutral, it always carries the intentions of its makers. If 3IATLAS represents technology rather than nature, if its impossible behaviours reflect design rather than accident, then we must confront the most unsettling question of all. What does this artificial visitor want? For in the realm of constructed objects, every capability serves a purpose, every function reflects an intention, every action reveals something about the motivations of those who built it. The visitor's behaviour patterns, when analysed through the lens of deliberate design rather than natural coincidence, reveal a mission profile that becomes increasingly clear with each observation. This is not random wandering through our solar system, but systematic reconnaissance conducted according to protocols that suggest specific objectives and carefully planned information gathering. Consider the observation hypothesis, the possibility that 3IATLAS was designed and deployed as a comprehensive surveillance platform, tasked with gathering intelligence about our solar system's planetary dynamics, biological development, and technological evolution. The visitor's trajectory modifications optimize its viewing angles of Earth and the other planets. Its controlled approach extends the duration of its surveillance window. Its variable luminosity might be testing human detection capabilities while measuring our response to anomalous phenomena. Human intelligence agencies employ similar reconnaissance techniques when studying foreign nations or monitoring technological development. Surveillance satellites are positioned to maximize coverage of target areas. Their operational parameters are adjusted based on the intelligence requirements of their missions. They gather data across multiple spectrums simultaneously, building comprehensive profiles of everything within their observation range. But the sophistication demonstrated by our artificial visitor far exceeds anything human technology has achieved. The object appears capable of conducting multispectrum analysis that spans electromagnetic, gravitational, and possibly quantum measurement techniques. Its extended operational duration suggests power sources and computational systems that can function autonomously for periods that dwarf human engineering capabilities. Most significantly, the visitor's apparent ability to modify its mission parameters in real time indicates adaptive intelligence rather than simple programmed automation. It responds to changing conditions, adjusts its observation priorities based on new information, and makes decisions about where to focus its attention based on criteria that remain invisible to human understanding. This adaptive reconnaissance capability suggests that 3IATLAS is not just gathering predetermined types of data, but conducting comprehensive evaluation of phenomena its creators could not have anticipated when the mission was originally planned. The visitor is learning about our solar system through direct observation, making discoveries that will inform future decisions about how to proceed with whatever larger objectives guided its deployment. But perhaps the visitor's purpose extends beyond passive observation. Consider the warning hypothesis, the possibility that this artificial object was sent not to study our solar system, but to deliver a message that transcends the limitations of conventional communication. Do you find it significant that artificial visitors appear during periods of rapid human technological development? Or do you suspect that their timing reflects evaluation of our species' readiness for information that could transform our understanding of our cosmic situation? Throughout human history, warnings have often been delivered through demonstration rather than direct communication. Lighthouse beacons do not transmit verbal messages, but announce dangerous conditions through their presence and behavior. Military displays of technological capability serve as diplomatic communication without requiring formal negotiation. Natural disasters serve as warnings about environmental limits without conscious intention to inform. An artificial object that demonstrates impossible technological capabilities while maintaining strategic distance from direct contact could be serving a similar warning function. Its presence announces the existence of intelligence far more advanced than anything humanity has achieved. Its behavior demonstrates technologies that could be used for purposes ranging from beneficial contact to complete elimination of human civilization. The visitor's restraint in revealing its full capabilities might be intentional, showing just enough artificial behavior to confirm its technological nature, while withholding demonstration of capabilities that might trigger panic or aggressive response from human military forces. This measured revelation approach suggests intelligence that understands the psychological impact of technological superiority and prefers to communicate through implication rather than direct demonstration. The warning might be temporal as well as technological. Human civilization has reached a critical juncture in its development, where our technological capabilities are beginning to pose existential risks to our own survival. Nuclear weapons, climate modification, genetic engineering, and artificial intelligence development all represent technologies that could either elevate human civilization to cosmic significance or destroy it entirely. An artificial visitor arriving during this critical period might be serving as a cosmic warning system, announcing that humanity's technological development is being monitored by intelligence capable of intervening if our choices threaten galactic stability. The visitor's advanced capabilities would serve as demonstration that such intervention is technologically feasible, while its restrained behavior would indicate preference for voluntary compliance with cosmic protocols. But perhaps the most disturbing possibility is the judgment hypothesis, the concept that 3IATLAS represents not passive observation or benevolent warning, but active evaluation of human civilization according to criteria that will determine our species' future relationship with galactic intelligence networks. The technological sophistication required for interstellar reconnaissance missions implies civilizations that have solved problems humanity has barely begun to consider. Resource management across multiple star systems, coordination of activities that span millions of years, development of technologies that can survive cosmic radiation, micrometeorite bombardment, and the absolute cold of interstellar space while maintaining operational capability throughout journeys that dwarf human historical timescales. Such civilizations would necessarily operate according to long-term planning frameworks that treat the development of individual species as data points in cosmic-scale experiments. They would evaluate emerging intelligence according to criteria that determine which species receive guidance toward galactic citizenship and which are quarantined or eliminated as threats to cosmic stability. The judgment process might operate through a series of graduated tests designed to evaluate technological capability, social organization, environmental responsibility, and cosmic awareness. Species that demonstrate readiness for contact through their responses to these tests would be invited to join larger galactic communities. Those that fail would be isolated until they achieved appropriate development levels or posed sufficient threat to require more direct intervention. 3IATLAS could represent one component of such a testing protocol. Its obvious artificial nature might be designed to measure human scientific capability, our ability to detect, analyze, and correctly interpret evidence of advanced technology. Our response to its presence could be evaluating our social organization, military restraint, and diplomatic protocols when confronted with superior technological capability. Most significantly, the visitor might be measuring human psychological readiness for contact with intelligence that operates on scales we can barely comprehend. Species that react to such contact with fear, aggression, or attempts to acquire superior technology through force would be classified as unprepared for galactic citizenship. Those that respond with scientific curiosity, diplomatic restraint, and acknowledgement of their own limitations might be deemed ready for more direct forms of communication. The lighthouse analogy becomes particularly relevant when considering the visitor's behavior patterns. Lighthouses serve multiple functions simultaneously. They warn of dangerous conditions, guide safe navigation, and announce the presence of advanced civilization to travelers who might otherwise assume they were exploring uninhabited territory. 3IATLAS might be serving all these functions through its presence in our solar system, warning us that our technological development is being monitored by superior intelligence, guiding us toward recognition that cosmic citizenship requires capabilities we have not yet achieved, announcing that the universe contains civilizations for whom interstellar travel and million-year mission planning represent routine operational capabilities. The visitor's electromagnetic emissions detected by radio telescopes during its magnetic field interactions might be serving a guidance function beyond our current ability to decode. Advanced civilizations might communicate through information encoding techniques that appear as natural phenomena to primitive observers, but contain structured data for intelligence sophisticated enough to recognize and interpret the embedded messages. The signals might contain technical specifications for technologies that could accelerate human development toward cosmic awareness. Navigation protocols for safe travel between star systems. Social organization principles that enable stable civilization across multiple worlds. Warning information about cosmic threats that require coordinated response from multiple species. But these communications would be encoded in ways that make them accessible only to intelligence that has achieved specific technological and social development thresholds. The information would be present but invisible until human civilization demonstrated readiness to receive and responsibly utilize knowledge that could transform our entire relationship with the cosmos. The timing of the visitor's arrival during humanity's transition towards spacefaring capability might be precisely calculated to coincide with our development of technologies necessary for detecting and interpreting such encoded communications. We are approaching the point where human radio astronomy might be sophisticated enough to recognize artificial information embedded in apparently natural electromagnetic phenomena. The cyclical nature of these artificial visitations, suggested by historical accounts spanning thousands of years, implies evaluation protocols that operate according to cosmic rather than human timescales. Each cycle might represent a new phase of testing as human civilization achieves new levels of technological and social development. The current cycle, characterized by obvious artificial visitors during humanity's transition towards space exploration, might represent the final evaluation phase before graduation to direct contact. The restraint demonstrated by 3IATLAS in avoiding close approach to Earth might reflect protocols designed to prevent contamination of the evaluation process. Direct contact could trigger technological or social changes that would invalidate assessment of humanity's independent development trajectory. The visitor maintains sufficient distance to gather comprehensive observational data while avoiding accidental influence on the civilization being evaluated, but this restraint also serves as demonstration of advanced civilization's preference for voluntary development rather than forced evolution. Intelligence sophisticated enough to conduct million-year reconnaissance missions would be capable of dramatically accelerating human technological development through direct technology transfer. The fact that such acceleration is not occurring suggests that cosmic civilization values species that achieve advancement through independent innovation rather than external assistance. The purpose of 3IATLAS, if artificial, extends far beyond simple reconnaissance or communication. The visitor represents humanity's entrance examination for cosmic citizenship, a comprehensive evaluation of our technological capability, social organization, environmental responsibility, and psychological readiness for contact with intelligence that operates on galactic scales. Our response to its presence will determine not just whether we pass this evaluation, but what kind of relationship we might have with civilizations that have learned to navigate the cosmos as easily as we navigate our own planet. Tonight, as you drift towards sleep, consider what it means to be under evaluation by intelligence capable of planning missions across millions of years and technological capabilities that make human space exploration seem primitive by comparison. Think about the purposes that might drive such advanced civilizations to invest in observing species like humanity during critical phases of our development. The artificial nature of our visitor implies intention, and intention reveals the motivations of its creators. Whether those motivations serve purposes that align with human welfare or operate according to cosmic priorities that transcend individual species' survival remains the most important question our civilization has ever been forced to consider. The lighthouse signals without words, warning of dangers and guiding towards safety. But the mariners who see its light must still choose their own course through the cosmic sea. Guided by the wisdom to recognize that some harbors are worth seeking and others should be avoided at all costs, the choice is ours, the evaluation continues, and the consequences of how we respond may determine the future of intelligence itself in a universe where artificial visitors serve as harbingers of transformations we are only beginning to imagine. To see the artificial is to acknowledge the maker, and to acknowledge the maker is to accept that we are no longer alone. The distinction between natural and artificial represents more than mere categorization. It marks the boundary between accident and intention, between random cosmic processes and conscious design. When we recognize 3IATLAS as artificial rather than natural, we cross a philosophical threshold that transforms our understanding of our place in the universe from cosmic isolation to cosmic community. Natural objects carry no messages beyond the physical laws that govern their formation and motion. A rock tumbling through space speaks only of gravity, momentum, and the blind forces that shaped it across millions of years of cosmic wandering. Its behavior reveals nothing about consciousness, purpose, or intelligence, only the mechanical interactions of matter and energy following patterns as old as the universe itself. But artificial objects are different. They bear the fingerprints of mind. Every design choice reflects a decision made by consciousness. Every capability serves purposes that extend beyond mere existence. Every behavior reveals something about the intelligence that conceived, constructed, and deployed the technology we observe. If 3IATLAS is artificial, then somewhere in the cosmos exists intelligence capable of engineering projects that span interstellar distances and geological timescales. Intelligence that can plan missions lasting millions of years. Intelligence that possesses technological capabilities so advanced that its artifacts can navigate between star systems, while maintaining operational status throughout journeys that would destroy anything human engineering has ever created. The weight of this recognition settles upon human consciousness, like the realization that we have been living in a house we thought was empty, only to discover that we have not been alone. That other minds have been present all along, watching, evaluating, making decisions about our future, based on criteria we are only beginning to glimpse. Do you find comfort in the possibility that artificial visitors demonstrate restraint in revealing their full capabilities? Or does their obvious technological superiority suggest that humanity's cosmic significance may be far smaller than we have always assumed? The search for extraterrestrial intelligence has consumed decades of scientific effort and technological resources, driven by humanity's desperate desire to answer the fundamental question of whether consciousness exists elsewhere in the universe. Radio telescopes have scanned the sky for deliberate signals. Optical instruments have searched for artificial structures around distant stars. Computer programs have analysed millions of hours of cosmic noise, hoping to detect patterns that might indicate intelligent origin. But the discovery of artificial visitors within our own solar system suggests that this search has been looking in the wrong direction. Instead of waiting for distant civilizations to announce themselves through radio broadcasts across interstellar space, we should have been examining the objects already present in our cosmic neighborhood, recognizing that advanced intelligence might prefer reconnaissance to communication, observation to advertisement. The implications of this realization extend far beyond astronomy into every domain of human knowledge and assumption. If artificial objects can travel between star systems, then the universe contains civilizations that have solved engineering problems humanity has not even begun to consider. If such civilizations are conducting surveillance of our solar system, then human development is occurring under observation by intelligence that possesses technological capabilities we cannot duplicate or defend against. Most significantly, if these artificial visitors are gathering information about human civilization and transmitting that data to their creators, then decisions about humanity's future may be made by minds that operate according to priorities and timescales completely alien to human understanding. The technological signatures exhibited by 3IATLAS, controlled navigation, adaptive mission parameters, self-repairing systems, million-year operational capability, represent achievements that place their creators centuries or millennia ahead of human development. The gulf between our current technological capability and what would be required to duplicate the visitor's performance is so vast that we might as well be comparing stone tools to quantum computers. This technological disparity carries profound implications for any future interaction between human civilization and the intelligence networks that created our artificial visitor. We would be approaching contact not as equals but as subjects, not as partners but as specimens, not as independent agents but as primitive intelligence undergoing evaluation by minds whose capabilities we cannot comprehend. The historical precedents for such encounters, recorded in the sacred text and oral traditions examined earlier, suggest that previous phases of contact between human civilization and artificial visitors involved direct technological transfer that accelerated human development beyond what should have been possible through independent innovation. Agriculture, metallurgy, mathematics, astronomy, many of the foundational technologies of human civilization appear to have emerged suddenly, without obvious developmental precedents, during periods when ancient accounts describe increased activity from artificial sky objects. If this pattern of technological guidance has been operating throughout human history, then what we consider our species' greatest achievements might be products of external assistance rather than independent human innovation. Our technological development might be following trajectories designed by intelligence that has been shaping our advancement according to criteria and objectives that serve purposes beyond human comprehension. The recognition that we are not alone carries with it the recognition that we may never have been independent, that human civilization might be a guided experiment rather than a natural development, that our choices about technology, social organization, and environmental management might be occurring within parameters established by intelligence that has been monitoring our progress since before we achieved self-awareness. But the artificial nature of our cosmic visitor also opens possibilities that pure naturalism could never provide. If consciousness exists elsewhere in the universe, if intelligence has learned to navigate between stars, if civilizations have achieved technological capabilities that allow them to conduct million-year missions across galactic distances, then the universe contains communities of mind that have transcended the limitations currently constraining human development. Contact with such communities could provide access to knowledge that would transform human civilization beyond recognition. Technologies that could solve energy production, resource scarcity, and environmental degradation. Medical capabilities that could eliminate disease, extend lifespan, and enhance cognitive function. Social organization principles that could end warfare, reduce inequality, and optimize cooperation among diverse populations. But such transformation would come at the cost of human independence. Accepting guidance from intelligence so advanced that its capabilities seem like magic would reduce humanity to a client species, dependent upon external assistance for continued development, unable to claim credit for achievements that were actually products of alien intervention. The choice between continued isolation and dependent advancement may be the most significant decision our species has ever been forced to consider. and the presence of 3IATLAS suggests that this choice may not be optional, that the evaluation period is ending and decisions about humanity's future are being made whether we participate in the process or not. The cosmic community implied by artificial interstellar visitors operates according to principles that transcend individual species survival. Civilizations that can plan missions spanning millions of years and coordinate activities across multiple star systems have necessarily learned to think in terms of galactic rather than planetary priorities. Their objectives serve purposes that encompass the development of intelligence itself rather than the welfare of any specific world or population. From such a perspective, humanity represents a single data point in a vast experiment designed to understand how consciousness emerges, evolves, and contributes to cosmic-scale objectives that individual civilizations cannot achieve independently. Our value would be determined not by our own assessment of human significance, but by our potential contribution to projects that span geological time and interstellar space. The artificial visitor in our solar system might be evaluating whether human intelligence possesses characteristics that would make it a valuable addition to galactic civilization, or whether our species represents a potential threat that requires containment or elimination. The criteria for such evaluation would be established by minds that have observed the development of countless civilizations across millions of years of cosmic history. Success would mean integration into communities of intelligence that could provide access to technologies and knowledge beyond human imagination. Failure could mean quarantine, technological suppression, or complete elimination if human development posed threats to galactic stability that could not be managed through less drastic measures. The weight of artificial recognition forces humanity to confront questions we've never been prepared to answer. Are we ready for contact with intelligence that possesses technological capabilities we cannot match? Can human civilization adapt to relationships with minds that think in terms of cosmic rather than planetary priorities? Will our species contribute positively to galactic civilization, or represent a source of instability that requires careful management? The answers to these questions will be determined not by human choice alone, but by the evaluation criteria applied by intelligence networks that have been observing our development since before recorded history began. Our cosmic visitors are not seeking our permission for contact. They are determining whether such contact serves purposes that transcend human preferences about our future. The silence that characterizes our artificial visitors' presence reflects not absence of communication, but communication at levels we are not yet sophisticated enough to recognize. The electromagnetic emissions detected during the object's magnetic field interactions might contain information that could transform human understanding of physics, engineering, and social organization. But accessing that information would require technological and conceptual capabilities we have not yet developed. The graduated revelation that has characterized recent interstellar visitors suggests that this information is being made available according to protocols designed to prevent cognitive shock while measuring human adaptability to cosmic realities. Each new level of artificial obviousness tests our psychological readiness for more direct forms of contact, while providing opportunities to demonstrate social responsibility in our response to superior technological capability. The ultimate question raised by artificial visitors is not whether humanity is alone in the universe, but whether we are worthy of the cosmic community that has been observing our development. Whether our species possesses characteristics that would make us valuable contributors to galactic civilization, or whether we represent potential threats that require careful management by intelligence, sophisticated enough to prevent us from posing dangers to cosmic stability. Tonight, as you rest in the quiet hours before dawn, consider what it means to recognize the artificial among the stars, to acknowledge that consciousness exists beyond Earth, to accept that intelligence operates on scales we can barely comprehend, to understand that human development is occurring under observation by minds that possess capabilities we cannot duplicate and purposes we cannot fathom. The weight of the artificial settles upon our cosmic awareness, like the recognition that we have been children playing in a vast library, unaware that adults have been watching our progress, evaluating our readiness for knowledge that could transform our understanding of existence itself. 3IATLAS blazes overhead as a messenger written in light and metal, carrying information about our cosmic situation that transcends any communication humans have ever received. Its artificial nature announces that we are not alone, that consciousness exists beyond our world, that intelligence has learned to navigate the cosmos as easily as we navigate our own planet. But recognition of the artificial carries obligations as well as opportunities. If we acknowledge that 3IATLAS represents technology created by intelligence, then we must also acknowledge that this intelligence possesses capabilities that could eliminate human civilization as easily as we eliminate bacterial cultures that threaten laboratory experiments. Our cosmic visitors demonstrate restraint not because they lack the capability for more dramatic intervention, but because they prefer evaluation to domination, guidance to conquest, cooperation to control. They have learned that intelligent species develop more successfully when they choose their own paths toward cosmic awareness, rather than having advancement imposed through external force. The choice remains ours. But the consequences of how we respond to artificial visitors will determine whether humanity joins the cosmic community as partners or remains isolated as subjects, whether we contribute to galactic civilization or serve as warnings to other species about the dangers of unguided development. To see Atlas as artificial is to admit we are not alone, and if we are not alone, then the universe has already reached out to us, not with words, but with machines written in light that carry messages we're only beginning to learn how to read. The conversation has begun, the evaluation continues, and the future of intelligence itself may depend on how well humanity learns to recognize the artificial among the stars and respond with wisdom worthy of cosmic citizenship in a universe where consciousness has learned to navigate between worlds.